Hello students. Yesterday we have discussed about the various factors and theories of drying. Okay. Various theories were there like diffusion theory, capillarity theory, pressure gradient theory, gravity flow theory, vaporization and condensation mechanisms. Okay. These were all the theories or the mechanism of drying process. In this, apart from this, we have also discussed about the factors. Okay, what are those factors which affect the rate of drying? Okay, and after that we have discussed about the EMC, that was equilibrium moisture content. Okay, so in our today's video we will learn more about EMC, that is equilibrium moisture content, or it comes under the terminology named as equilibrium relationship. Okay, so yesterday I have told you that what is EMC. Let me revise it once, that it is the amount of water that is present in the solid and it exerts a vapor pressure. Okay, some amount of water that is present in the solid will exert some amount of pressure, and that pressure is equal to the vapor pressure which is present at the atmosphere that is surrounding that solid. Okay, so this is known as equilibrium moisture content. The moisture which is more difficult to remove in the practice is in the equilibrium moisture content. Okay, there are some moisture which cannot be removed by the solid particle. Okay, we have studied in our earlier videos of drying. Okay, so that moisture content is known as equilibrium moisture content. Okay, so if in this, when the moisture content is retained by the solid and the conditions are stable conditions are there. Okay, so this water or the liquid which is present in the solid does not vaporize and does not produce any vapor pressure. Okay, so from that point full vapor pressure cannot be developed. So equilibrium moisture content in a wet mass, you can see this in the diagram which I have created for you. You can see this. There is the diagram is in the two parts. In the first part it is mentioned over there that in a beaker we have taken a wet mass. Okay, wet mass is present. This is at equilibrium state. Okay, in this what is happening? The vapor pressure of the wet mass minus the vapor pressure of the atmosphere. Okay, so means that amount of water that is present in the wet mass is your EMC. Okay, now the characteristics of the air such as temperature and the humidity. Okay, these are what? Temperature and humidity are the characteristics of the air. Okay, if we are maintaining it constant, means if we are maintaining a constant temperature and constant humidity, so what will happen? Okay, when air is at constant temperature, air is having a constant temperature and constant humidity, and it is continuously passing over the solid, so that solid which is containing moisture and it is more than the EMC is your equilibrium moisture content. Okay, then the solid loses water continuously till EMC is reached. Okay, so this phenomena is known as desorption. Okay, what is desorption? Let me again explain you that if the air of constant temperature and constant humidity is continuously passing over the solid, then the solid starts losing water continuously till that when it will stop losing the moisture, when the EMC is achieved. Okay, when it will reach the equilibrium moisture content point, then this phenomenon is known as desorption. And what happens in second case? If the air of again constant temperature and humidity is continuously passing over the solid that is containing moisture less than the EMC. In desorption, what was happening? The moisture present in the solid was more than EMC. Okay, and In this case, if the moisture present in the solid is less than EMC, then the solid absorbs water, okay, continuously till EMC is reached. This phenomenon is known as sorption. Okay, you can see in the next part of the diagram what happens in desorption and what happens in sorption. In desorption, what is happening? Moisture is leaving the solid part, and what happens in sorption? Moisture is gaining by the solid body. Okay, so this was your desorption and sorption. In EMC, there is a terminology called as FMC. FMC is free moisture content. Now, what is this FMC? It is the amount of water that is free to evaporate from the solid surface. Okay, free means that is easy to evaporate. Okay, what happens in this? Under this condition of this saturation humidity, what will happen? The EMC is the minimum moisture content. Okay, so water must be bound water which is minimum at that temperature, and the remaining unbound water for which the FMC is a given condition. Okay, now next is your rate relationships. Now what is this rate relationship? It can be considered by a simple model like conditions of a dryer. Okay, what will happen in this model? A wet slab of material of sufficiently high moisture content is to be dried. Okay, and it is placed in a tray whose bottom and sides are insulated. Okay, now the air is blown over the solid under constant drying condition. Like constant drying condition means the velocity of the air, the temperature of the air, humidity of the air and pressure of the air. These all characteristics of the air is being maintained constant. Okay. Now the superficial water diffuses through the surrounding stationary air film and it is carried away rapidly by the moving air stream. Okay. Superficial water means the water or the moisture part that is present on the surface of the solid. Okay. So it can be explained by this rate relationship. There is a equation that is LOD, MC. What is this LOD? This is the loss on drying. It can be expressed in percentage. Okay. So what will be the percentage loss on drying? Means the mass of the water in sample divided by total mass of wet sample. It will be multiplied